Hello to my fans, to my subscribers, to my viewers, those who are part of and parcel of this channel. I want to say hello. I'm trusting that you're all well and you are enjoying these sessions as they come along. So today is another chance to also bring in place additional content in regards to the standard methods of measurements and the rules that we've been covering since the start for the beginner series. So at this juncture, I would like us to go through reinforcement, but before then, as usual, I would introduce myself again. My name is Buxton. For if you are new to this channel, my name is Buxton Ochieng, and this is a channel of construction, surveying, tutoring. It entails you, or it requires, it tries to spread the knowledge in the fields that are suggested in the name, that is construction and also surveying. Now I would urge you to subscribe to this channel, because if you haven't come across some of the videos, then this is definitely the first one for you, but you are going to enjoy it. It brings to you authentic explanations of the skills in construction, especially in surveying, which is very marketable and crucial for you. In the previous session, we were able to learn about piling and concrete work in regards to the rules of standard methods of measurements. Upon coverage of these, just to put it on also on record, that upon the time when we are finished covering the standard methods of measurements, this channel is worldwide. It covers both domestic within the locality and also across the borders. For that reason, you will notice that we'll also be able to cover other rules of measurements or estimation, including the new rules of measurements 2, standard methods of measurements 2, as I had previously explained in the beginner series 001. So make that in mind, have that in mind, that we are going to cover that, and at the end of the day, all those who are visiting the channel should be able to benefit. So this welcome to beginner series 005. Hope it will be worthwhile your time. Now we move forward. From the slide that is presented, you can notice there is a reinforcement, bending, and also now setting them in place, ready to receive the concrete work. So the intention, at the end of the day, intention of us covering these coverages is because that you have a vivid description of what you're looking at in terms of theoretical explanation, and also explanation in terms of how you would work out that for your estimation. So that's quite crucial, because I believe that for you to carry out a successful estimation, you really need to have in mind what it really is and how it can be done. So in that way, you are able to estimate easily in regard to all that it entails for that given item. So that said, we would go straight to some of the basics of reinforcement. Of course, there are the types of reinforcement. We'll have the Y or the T. Now those are the high tensile, and also the mild steel. So of course, depending on which one you are applying, or for what purpose you are using that given reinforcement bar, then you will select now the appropriate one. And of course, now the design for structural is also bestowed on the structural engineer, but then you, as an estimator or the quantity surveyor, you basically need to know, you really need to know at your fingertips now the type, so that you are able to, at times you can assume when those details are not provided, so you make the right or informed assumption for that matter. Yeah, that's why I've talked about, there is an abbreviation for that, is a Y or T, that we'll look into later on. So Y/T simply means now the high tensile bars, especially used for reinforcement. Yeah, also they also come and they are always described in terms of the diameter of those specific bars. Okay, and you'll also see how the diameters, now when we'll come to actual estimation or calculations, you'll also notice that those diameters directly relate to now what you have as the ultimate pricing of those given reinforcement bars. Okay, so in this case now we have some of the processes that are involved in the bars. Now we have fabrication and fixing and tying and placing. Of course, now those are the determinants of you inputting the prices to against the unit that you are yet to learn just in a shortcoming moment. So from what you have now, I've said you talk about bending and cutting. Now those are now the activities that will lead to you having your reinforcement in place. Then what you have here is now just there's a formwork, and then you have now the reinforcement still in it. So for relevance and also to stay focused on this course, there are these of items that you might be aware of, but then now we emphasize on now their relation of those items that you know, their relation to now your estimation, so that you put it into perspective for those that you might have seen it somewhere but you are not certain of how to carry that forward into now actualization of giving it an estimate. So we need to learn the type of rules or the specific rules that guide now for you to take off the reinforcement. What do you need to refer to, okay, and how do you do that now in real sense and price and so on. That is now coming to and at later stages of our series, beginner series, for you to learn. Okay, yeah, so these are some of the sequence that are available for our construction, and you can see them there. We have now bending. You've bent the bars, you've now prepared them in the shape that is required, and then you have the formwork. It's placed in position, ready to receive the concrete, yeah, plus all those considerations for the spacers and so on. Once that is done, and then now yes, this is just to show you a description or for you to actualize and internalize what we are talking about in terms of the reinforcement sequence of placement. Yeah, so the reinforcement bars to slab. So these are just examples. Yeah, these are items that you might have interacted with them while on site or not. So this channel now wants to put into perspective of how did they arrive to bringing this number of bars in place, or how did they arrive to the cost of this particular reinforcement for given elements for that particular work. So that said, then we have, of course, we have different ways of placement. When you have like here we have the beams, there is a tying wire and so on. So the tying wire, you have the long main bars, okay, and then now you have the ones that are called the links that are now put across, especially for columns and also for your beams. You'll have those links. So we'll see now what does the rule states about this. Yeah, we've talked about reinforcement. This is how it looks like, how they are placed. Okay, yeah, so these are some of them. Let me just try to show it even better, if you can you're able to see it even well. Yeah, that's better. Yeah, I'll override the one at the back so that we focus on this one for now and see how it's looking like. Yeah, so let me just do away with that one. Yeah, so this is an example of the reinforcement that they have been placed, ready to receive the concrete, and that is it. So I would like us to look into the standard methods. What does the standard methods say of how to now carry out the measurement for for those particular item of reinforcement bars. So for the standard methods of measurement, that is now the SMM, it talks about the kgs. Okay, so when you are carrying out the estimation for bars, you talk about kgs. Okay, but then you can notice that when you look at our layout in terms of how the reinforcement bars are placed, you can't directly tell how many kgs is that, but then you can tell the length of those given bars. Okay, so let me take you to the bills of quantities and we see how that has been expressed. Okay, you look at this, we are talking about reinforcement. So in this case they were assorted. To assort just simply means that you measure all those items as one, rather than separating them in terms of the diameters that we've just talked about. So for every specific type of bar, for example, talk about D8, D10, D12, D16, D20, D25. All those are expressed in terms of the kgs. Okay, so how did you arrive to kgs? So I'll just give a hint, because these are quite an interesting topic that I always enjoy explaining so much, and however much hectic it is, but it's very interesting. You always feel the thrill when carrying out items to do with reinforcement. So I'll give you a hint. Unlike the other items, I'll just give a hint to how we'll carry out this particular one, so that we appreciate how this was arrived at. Yeah, so normally you talk about the specific items that is making up the kgs for that particular item. So for instance, I'll give an example that we are talking about. Let me just leave this alone. Yeah, let me just give an example based on a different one. So for instance, you have a beam. We'll talk about for instance a beam, and your beam is say 10 meters long. Okay, so for the 10 meters long, you say for instance you are using D12 bars for the main bars that are running along. Okay, so for the 10 meters you will take for example 10 meters. So you'll have the length. You focus on the length because that is now what you can directly take off or measure from your given elements that have been provided. So you take the 10 meters and then you multiply by 4. Okay, because you're assuming that you have 2 top and then 2 at the bottom of that particular beam. Okay, so 10 times 4, that is now the total length. Once you have that, then there is now a relation of the length, and then we now convert it into kgs. So normally it's the length that you have. Okay, you have the length and then you multiply by the diameter of that particular bar. Okay, squared. That gives you we've talked about, it was D12 times 12. Okay, and then you divide by 162. Okay, so just to summarize on this, 10 is the length of that beam, ideal beam that we are talking about, that we are using for explanation. So the 10 meters then times 4, assuming that there are 2 at the top, 2 at the bottom, so that is 10 times 4, and then you multiply by 12. Now that is the diameter squared. Thereafter you divide by 162. So 162 is basically a constant that is now used to convert length of the particular reinforcement bars now into kgs. So at some instance you might realize that there are those that use specific constants, for example 0.0888. Those ones are normally now a converted figure arrived at through the diameter square divided by 162. So once you have that, and then you should be having your kgs. So that is now kgs for the main bars. Okay, but then now you'll need to go a step notch higher and also add the bars for the kgs for the links, so that you have a full reinforcement for that particular beam. Okay, So you have that, you have the kgs for that particular one. And then we can also add to it just another addition. We can also have to it now the links that we've said. So for the links, we'll assume D8. Okay, so D8, and then our beam, for instance, it's a beam of 200 on the breadth or the width, and also at the depth is can talk about 450, yeah, which is now let's talk about 300, so that we just talk about an average size of beam. Okay, so you understand that we'll also talk about this further now when we'll be taking out from the actual drawings, translated into quantities, and also price, and make up the full bills of quantities. But for now, because I told you that this is an area that it's so interesting to me, it's one of those items that I've decided to bring in-depth explanation in how to carry out their works. So we talk about the links for the reinforcement beams, and then this is how it goes. So we've said that we are going to use we are using an example of 300, 200 breadth, and 300 deep beam for that particular structure. So what we need to do first is get the length of that link. Okay, of course, when you're talking about reinforcement, there are items like reinforcement cover that is also always taken into consideration. Okay, so in this case we are using an example of cover of 50, or let me say 25. If you talk about cover of 25, then at the top it's 200. Okay, top and bottom, because the width of that beam is 200. Okay, so for the 200, then we talk about 200 minus the cover on both sides. Okay, that is 200. Let's just calculate the length first. 200, then we less. So 200, then we less, now from the 200 we less 25 on either side, so that is 25 times 2. Okay, so that we have now the length of the reinforcement bar at the bottom, now the width in that case. Okay, so that is that we get 150, and then we add to it. Okay, yeah, so from this we add to it what we call now on the depth of that particular beam. We said it's 300, therefore we need to do 300. We can put this into bracket so that we don't have a mix up in terms of what we are carrying out. So we have 300, then we do the same, 25 at the top for concrete cover, and also 25 at the bottom for concrete cover. So that is also another 25 times 2. Okay, so that brings us to the total for a length and width. Okay, so in this case we can just add another bracket to the outside, so that we take our resultant figure, we multiply it by 2, because we're now having just basically a perimeter of that particular reinforcement bar. So we multiply by 2. Okay, but then we need to add for the hooks for that particular bar, because you'll notice that once you've tied the link, then it has to overlap in a certain way. So all those will be covered later on while be moving deeper into details of these reinforcement bars, why they cover, and so on. Yeah, trust me, these items very interesting, and you will learn it even more and more as we go on. So we can take the hooks to be, for instance, let's just take 50 millimeters in this case, 50 times 2, that given way. So we have 900 millimeters for the length of that particular link. So once we have the length, then we now adopt the other procedure that we had. So this is now the length. Of course, the length has to be in meters. Okay, So that is 900, so that will be 0.9 in terms of meters. Then you multiply by the diameter squared, so that is 8 times 8, then you divide by 162. Of course, there is something that we have missed out: the number of those bars. They are links spaced at 200. Okay, so let's talk about that here. So in terms of the number, so this is 0.8 is one of them, and then we multiply by the number. So in bracket, let's do we said it's an ideal 10 meter long of beam. So it's 10, you divide by the possible spacing. So in this case, let's talk about a spacing of 0.2 meters. Okay, so from at a spacing of 0.2 meters, and then you multiply by that. So in this case, we should be having kgs of 17 kgs of reinforcement. Then we now add the main bars, which were 12 millimeters dia, and then we add to now the links, that is now 8 millimeters dia, and then we have 53.3 kgs for that particular reinforcement of that particular beam. So you can now relate now from your length that you have, from the length you can now relate to how you arrive to kgs. Okay, but because just to bring in point, because now that mode of measurement is constant across for the work that I've handled, that method of measurement is constant in terms of translating your length into can either be, so for instance, if you are using other forms of measurement that requires you to do it in turns, let me say new rules of measurement, then you simply need to have a way of converting this. So if you don't have a constant of converting your length, because that is definitely what you are going to get from your so-called drawings. Okay, so once you have your length, then you might be having a constant that has already been done for you to convert that length into kgs, into tons. Alternatively, you can be having other constants that are done for you also to convert it into kgs. But as you are aware that the relation of numbers is constant across, so even if you are watching this video from a different part, not within the domestic geographical area of standard where the standard methods of measurement is applicable, then you have your kgs. It can easily be converted into tons by dividing by 1000. So I told you that reinforcement is quite interesting because of the diversity. So there is no much, if it's a reinforcement bar, you do it in kgs here, and you need it in tons, you can straight away do that. You can also Google conversion factors. Conversion factors may be online in terms of those conversions. That can also be done in just a click. So it's interesting, but then you need to know how they build on each other in terms of how to relate and how to do your measurement and get your estimation right. So that is well explained, I believe so, and it's really going to help you moving forward, so that even before we now get into actual calculations, which is now going to be done on real time or based on the actual drawings that have been done, and then we now do them together one-on-one till you understand what it means and how it goes. You now have an idea. In fact, what you have, you can now take off a basic structure. You can now take off and measure just the reinforcement of a given beam, column, because it's so interesting and so easy based on what I've explained to you at just now. So also another part of reinforcement that we're talking about now is BRC. That is now the British reinforced concrete reinforced cement. Now in this case we have the mesh. Of course, meshes that are of different specifications based on the strength and also the purpose. So based on whatever you have, this is now what we call A142. That is quite stronger. Then we have A196, A66. Now those are the smaller ones. So and so on and so forth. So depending on what you have, Of course, the pricing which you also come to realize later on depends on now the cost of material, labor, and so on that will be built up as we come along in terms of our coverage and estimation as we go on and on with them. Now this one is done in square meters. You can just confirm from this is now the fabric reinforcement. This one is here. Okay, so let me just highlight if you can't see that well. Yeah, so we have it in terms of square meters. Okay, so you can find it there. Yeah, basically you have to remember that this is still part of section F, talking about concrete building up in terms of all the items that are associated with it, including reinforcement, including formwork, because it's one and the same thing. But then they are different in terms of the materials associated with them and how it's done, but it's under what we call reinforcement work. So all those are falling within the section F of the standard methods of measurement. And this is across as well in terms of the works I've handled. It's also across in terms that also in those other areas, those other rules, you'll find that concrete, and then there's also a subsection of concrete works. There's a subsection of concrete, there's a subsection of fabric reinforcement, bar reinforcement, and so on. So we've talked about that, and I believe it's quite well taken for you in terms of understanding. Now we move next to another section of the last section on the coverage for this particular session. That is now the formwork. Yeah, you want to just see how this is carried out. So for your formwork, then what you need, formwork depend on where you're laying it, or the purpose of doing that given formwork. If you're doing formwork in terms of let me just give a brief presentation here so that we see. Yeah, so we are talking about formwork, in whose definition can be, as it has been presented there, mold or open box container into fresh concrete is poured. Yeah, definitely you understand why you have to put it there. Fresh wet concrete doesn't have the strength to shape and the size as per the design, so you need to reinstate it within a particular size so that you have the size that was designed. You contain that particular strength after compacting and vibrating and so on. So in brief, that is the reason why you have your formwork in place. Okay, so there are different types. You can have steel, you can have plastic, you can have timber formwork, aluminium formwork. They come in various varieties, as you can see. But then now the goal is one. The goal is for you to actualize what we are talking about in terms of formwork, and then you also try to picture where you are going to use that formwork. Of course, understanding the reason, then you'll have to know that beams, you'll have a formwork, columns, you'll have a formwork. If you're having a suspended slab, you also have a formwork in that case. So all that's taken into consideration. Then I've told you in terms of this is another one looking like ups and beam that you have, and then it's supported by bracings. This is now the traditional timber. Yeah, it still works. Yeah, depending on quality that the intended quality that you need for your final product. Okay, formwork determines a lot the quality of what you need in terms of the product. For instance, if you use a plain sheet, you can use plain sheet in some instances. You will realize that you have a fair finish of concrete at the end of the day. So depending on how much you're cutting the cost, depending on the quality that you need, different formworks have different purposes, and as long as it works for you, it's suited. But then you make sure that that given quality is always a priority at every particular time. So this one is going on. You can see there is that casting is happening there. Yeah, this is also another. This looks like a ground beam. Casting is done, vibration of that concrete, and so on. Okay, so after that is done, you install it in a place, of course, after you've done your reinforcement, yeah, based on the program that is applicable. But then definitely you set in your formwork, you set in your reinforcement, then you now come and tie in your formwork in that given area. So once you have that, then now you as a quantity surveyor or an estimator, you need to know how this is done, because you've already pictured out items involved within this particular in setting out this particular formwork. Now you need to know how this is done. So in terms of rules, we'll talk about, there is always what we call categories of formwork. Okay, so those categories will determine of how you are going to take them off. So talking from the foundation, for instance, you have to the sides of what we call sides of the foundations. Okay, that is done in square meters. Okay, size of foundations in square meters. You can have pad foundations, you can have also just what we call the size of the strip footing. So in that case, just get the length and get the width. So the width of that particular formwork is directly related to the width of the depth of the concrete that you're casting in place. So that is the depth that you use. If you're using 200 millimeters thick, then get the length of that your strip footing, then you multiply by the depth of the footing, which is the 200, then you get the area on both sides. Okay, when you're talking about pad foundations, then it is the total length. So for instance, you're talking about a square pad foundation of 1000. So do 1000 times 4, you get the total length. Okay, then you multiply by the depth of that. Let me say it's 300 millimeters deep, multiply by 0.3, you get your area times the number of column pads in that particular manner. Go to the stub columns. These are now the columns at the foundation level. Okay, you do it in square meters. Okay, so you can get your girth, what you call the girth, which is basically, if you are, for instance, you're dealing with a column of 200 by 300, so you do your girth by adding the 2 plus 3 times 2. Okay, that is the 5 times 2 is 10. So that is 0.2 plus 0.3, that is 0.5. So that brings you 1 meter in terms of girth. Then times the height, maybe it's 1. You do that, multiply by the number of columns up to the superstructure level. Let's see if there is another X. Yeah, now this is now a column. Yeah, up to the superstructure level, we can talk about now. We start from the column. Column are the way you've done whatever you've done for the measurement for the substructure is the same to the top. Okay, of course you need not to worry much about the details for today and the actual calculations, because we are covering the rules from the moment, and then later on in the later stages we're now going to carry out the actual measurements of these particular items that we are talking about. So there is no need to worry, you are going to understand them so well that from here you just request any drawing that you want, do your estimation. If you have not done it, if you are an architect watching this, you are able to interrogate the quantities you are given there, because you already have the basics, you already know the rules that guide these items that we are talking about. So for the beams, it's also in linear meters, so the sides and soffits of the beams. Okay, that is if they are suspended. Of course, if it's ground beam, just to the sides. Suspended beams, then you do sides and soffits. You do the girth, okay, that you'll also see later on. Do the girth in terms of depth times 2. Okay, then you add the width. Okay, after having the girth, now you get the total length of that particular beam. Okay, so once you have that, you get your square meters. I believe if you're talking about wall, square meters also, length times the height. So that is a basic or a general summary of your rules that guides that is guiding your estimation for formwork in various items. So that is quite basic and quite on point, because that is why this channel is there, to make sure that you have your rules at fingertips, well summarized, without having to shed so much sweat into trying to dig out from where is this, from where is this. Gives you everything straight to the point, because that is what you need. You need it synthesized, you need it direct, you need it in a more summarized manner. So that is why this channel exists, to make sure that you have that summary, you have it well explained, you have it everything at your fingertips. So that brings us to the end of our session for today, beginner series 005. That was focusing on concrete work. No, I mean it was doing our what we call reinforcement and also formwork. Okay, so that brings us to the end of our session today, and I want to deeply thank you so much for watching this video. You are a great member to this channel, and I would urge you to, as you watch, please subscribe, because it's definitely worth it. It summarizes for you the work, it gives you everything that you need. It also summarizes and very much accurate that you're not going to find in any other channel that is out there. So please subscribe to it, share much, and let's learn together, let's learn to share, let's learn to grow together, enjoy learning together. Thank you very much, have a fantastic time, and let's link up in the next session. Bye bye.